of equations today, but I want to look at systems that have 3 variables instead of just 2. In order to solve a system with 2 variables, we had to have 2 equations. If it has 3 variables, we're going to have 3 equations in order to get a solution. So typically I will use X, Y, and Z. It could be any letters. When you write your answer, you just put them in alphabetical order. When you're writing, in this case, not an order paired, order triplet at the end. So let's just jump in. We're going to do the same strategy, substitution and elimination, so no new techniques. The problem just is a little bit longer because we have more equations to solve. Keeping your work neat is going to be very, very important on this. So what we're going to do is take 2 equations at a time, and we're going to eliminate the variable. So give me, which 2 equations do you want to start with? First 2, sounds like a great option. If you pick the first 2, which variable do you want to eliminate? Z? Okay. So if I'm taking the first 2 equations, if I want to eliminate Z, what would I do? I have to multiply the top one times 2. Okay. So I get 2x plus 2y minus 2z equals -2. 4x minus 3y plus 2z equals 16. So I add those together. All right. It's better, but can I actually solve it and get an answer yet? No. Now, this is where work becomes very important. I have not yet used which equation. So I have to use the last one, and I can use one of the other 2 with it, and I need to eliminate the same variable. So I just eliminated z. I'm going to have to eliminate z again. So let's say I took the first and the last. If I were trying to eliminate z, what would I multiply by? That gives me -3x minus 3y plus 3z equals 3, and I'm pairing that with the last one. If I add these together, -3x plus 2x, -3y minus 2y. These cancel and equals 8. So, very important. We start by taking 2 equations, eliminate the variable. Then you have to take the equation you have not yet used, pair it with one of the others, and eliminate the same variable. The reason that's helpful is because now, when I look, both of these equations involve x and y. So now I can put those together and eliminate something. So if I wanted to eliminate y, what would I have to do? If you didn't eliminate the same variable the first time, then you wouldn't have been able to put those equations together. So that's why we have to do the same variable. Now I have x, so I can start working backwards. Once I've got my x, I can plug it into either of them. So if I just plugged it in right here, then I can get my y. So now I have my y. If I want to get z, where do I have to plug that in? One of the top ones. Doesn't matter which one, so if I just went with the first one. X was 2, y is -2. So then z is 1. You can check them. It should work for all three equations when you plug them in. So you can always do that. When you write your answer, just alphabetical order, x, y, z. So x is 2, y is -2, and z is 1. All right. So much longer process, but the same strategies that we had before. So pick two equations. Let's say I just went with the first and the second. You have to eliminate a variable. So if I wanted to eliminate y, what would I do? Which equation do I have to use next? Okay, have not used the last one, so I have to take it with one of the others, and I have to eliminate the same thing. So I'm looking to eliminate y. Which one do you want to put it with? Top one, so we can just take top one times 3 again. take these two and eliminate something. This is not real pretty. So if I wanted to eliminate x, what would I have to turn them both into? You could go 24. So you could take the first one times 4, and this one times -6. 12 would also work. So whatever jumps in your head, it works as long as you can get them there. And I get my z to be -4. Once I have z, I can start plugging it back in. So if I just put it in right here. And get my x to be 1. Once I have x and z, plug them back into one of the originals, so I'll just go with the first one. So the first one, my x is 1 minus y is 5 times z. So your answer, x, y, z. So x is 1, y is 2, z is -1. And if you want to check, you have to put it back in. All these we can see 1 plus 6 minus 2 gives us 5. 3 plus 6 plus 1 is 10. 1 minus 2 minus 5 is -6. So you can always check them. Has to work for all 3. Okay, what questions do you guys have so far? Now, this problem, when I look at, I have 3 variables. So I told you in order to solve it, if you have 3 variables, you would need 3 equations. I didn't give you 3 equations. So that means you're not going to actually get a numbered solution. Remember some of them, before we got infinite solutions and we had to write it in terms of one of the variables? So this is telling me to write this in terms of x. Since I only have 2 equations, I can't figure out what the number is. If x is the variable I'm keeping, then I have to find expressions for y and z, where x is the only variable. Which one's easiest to solve for? The second one. You could take this equation and solve for y right away. So y is 4 minus 2x. So we already have x and y. How would we get z? You could work with an elimination and eliminate maybe the y and then solve for z. That would totally work. The other option is substitution. Could you substitute your y in up here? Yeah, so either way, since I already have this one as y equals, I'll just do substitution. So I'm going to replace my y, 4 minus 2x. If I distribute my negative 2, I get minus 8 plus 4x. Add over my 8 is 15. Remember, we're trying to solve for z. So 3z is 15 minus 5x. Divided by 3, so z is 15 minus 5x over 3. So we didn't actually get the number solution, but if we had an x value, we can now easily figure out what y and z are to go with. Any questions on that one? Let's do a word problem, just for fun. We did them yesterday. An investment of $35,000 was made by a business club. The investment was split into 3 parts and lasted for 1 year. The first part earned 8% interest, the second was 6%, and the third was 9%. So what are my variables? Okay, I already know it was 35,000 altogether, so what's my first equation? And how many equations am I going to need? 3. Okay, the total interest was $2,160. So what's my next equation? So just our variable times the percent. All right, the third equation says the interest from the first investment. So my first one was the x. The interest from it is the 0.08x. Was is the same thing as equals 2 times the interest from the second. So my second one was y, that interest was 0.06y. Find the amounts of the 3 parts of the investment. Okay, if I look, my last equation only has which variables in it? X and y. So what I would do is start with the first 2 and get rid of z. Since my third equation already doesn't have a z, let's get rid of it here. To do that, I would have to multiply the top one times negative 0.09 because I'm getting rid of the z. Oops. these together. Get negative 0.01x minus 0.03y plus negative 540. What do you want to do next? I have not yet used the third equation, so I have to use it somehow. Do you want to just solve for x in the third equation? I take that, 0.08x equals 0.12y. So if I divide by 0.08, then x is 3/2 y. So now what could I do with that one? Substitute into the x over here. You could have also set those up to do elimination together either way. So if I combine like terms, divide by negative 0.045, and we get what? Once we have y, we can plug that back in and get x. X is 3/2 times y. That means x is 18,000. And we can go back to our very first equation, x plus y plus z equals 35,000. And then how do I have to answer this? Yep, it's a word problem, so we have to write a sentence. So they invest $18,000 at, X was 8%. $12,000 at 6%. $5,000 at 9%. What questions do we have there? Last one for the day. I want you to take a second and try this one. We're taking the first two equations, and we said we want to eliminate z. Do we have to multiply by anything for that to happen? No. Okay, so the first equation plus the second equation When we add those together, 1x plus 2x is 3x. Negative 1y plus 3y is 2y. Negative z and z cancel. 1 plus 2 is 3. Did everybody get that when you added those first two equations? Now, I have to use the third equation because I have not used it yet. But I'm in pretty good shape because it doesn't have a z. So I can go ahead and just put it with this one because neither one has a z. So if I wanted to eliminate x, what would I have to do? So let's say I take this one times the negative 1. When I add, negative 3x and positive 3x cancel. Negative 2y and positive 2y cancel. If everything cancels, that's just 0 equals 3. Does 0 equal 3? So what does that mean? And what other word do we write along with that? I told you on that first day that the directions these will always say solve, identify any inconsistent systems. So if there's no solution, it is inconsistent. All right. These problems are longer, but we have a strategy that we're using every time. So it's pick two equations, eliminate a variable. Then we have to use the third equation. Eliminate the same variable. And then we put those two answers together. So it is a series of elimination. The assignment, there is Math Excel. You will notice it is due Thursday. I am not moving on tomorrow. So we'll do a couple more examples tomorrow if we need to, and you will have some class time